In example 7, we're still looking at using the addition rule for probability to find the probability of two events that are either mutually exclusive or not mutually exclusive. But now we're reading that information off of a table. In this case, a table that tells us the enrollment at a certain school by class year and area of study. In part A, we want to find the probability that a randomly selected student is a first year or a sophomore. In this case, those are mutually exclusive events. A student is either in their first or second year of school. To figure out the probability that a student is in their first year, we need to determine the number of first year students. So there's a total of 856 out of the total of 3,534 students. So that probability will be 856 over 3,534. And we'll add that to the probability that a student is a sophomore. There are 838 total sophomores. So this will be 838 out of 3,534. So this gives us a total of 1,694 out of 3,534, or approximately 0.4793. So we have a 47.93% chance of that randomly selected student being either a first year or sophomore student. In part B, now we're asked to find the probability that someone is majoring in healthcare or modern languages. Excluding the possibility that someone could have a double major, we're going to treat these as mutually exclusive events. You're either majoring in one or the other of those areas. So in this case, we'll look at the totals along the right-hand side. There are 997 students who are majoring in healthcare. Out of the 3,534 students. And there are 909 students who are majoring in modern languages. Adding those together and then dividing would give us a probability of 0.5393. In part C, we want the probability that a student is a first year majoring in healthcare. Now we have events that are not mutually exclusive, so we'll need to look at subtracting out the overlap where a student falls into both of those categories. But we'll start with finding the probability that a student is a first year. That's a result we already came up with in part A, which is the 856 out of 3,534. Then we need the probability that a student is a healthcare major, which is 997 out of 3,534. We'll add those together, but then we need to subtract out the overlap. The overlap is the group of students we double counted, those who are first years and healthcare majors. In this case, that's 288 students. So we'll subtract out 288 divided by 3,534. Add and subtract those fractions to get 1,565 over 3,534 for a probability of approximately 0.4428. In part D, we want the probability of selecting a senior who's majoring in humanities. So we have 1,028 seniors. We have 817 students majoring in humanities, and we have 259 students who fall into both of those groups. This means we'll take 1,028 divided by 3,534. We'll add the probability of selecting a humanities major, which is 817 out of 3,534. And then we'll subtract that overlap, the 259 students who fall into both of those categories, to get 1,586 out of 3,534 students for a probability of 0.4488.